Continuing on page 197, we are going to look at the various graphs of various functions. Now first, let's look at the graph of a constant. If f of x is some constant such as, I don't know, 5 or something, or 3 or anything else, then you will have a horizontal line like this. In this case, f of x is 2, so you have a line with a height of 2. And so let's look at the next page. Okay. By the way, if you're familiar with graphing, you can skip over this point because I'm going to describe in detail how to graph stuff. Although you should at least look at page 1, the next couple of pages to be familiar with what each graph look like. Okay. But other than that, you may skip over until you don't see until I take that thing off. But anyway, so if we look at the following page, 198, then we have various functions, and they have different shapes. Now, what I want you to do, okay, well, first let's turn page 199, more functions, all with interesting shapes. What I want you to do is, if you're not familiar with plotting functions in the Desmos Graphics calculator, I have the link in the video description below. So please, I have instructions on exactly how to do it. Please plot all these functions, every single one of them listed here, into the Desmos Graphics calculator. It won't take you very long because you just have to type it in. And I have instructions on how to type it in the video description as well, in general. And then for those who are not familiar with this kind of thing, I wrote down exact instructions on how to do this. Okay, so let's look at that. Let me show it to you. Okay, here are the exact instructions. That is, I typed in every single button, that you need to push in order to get this to come out, to type in those functions. So please at least do these. And if you follow the instructions exactly, you see I have all the buttons listed. The buttons that's 2 in a stack, that means you have to push them together. Yes. Okay, so please take a screenshot of this thing and then type in all these things. There are 4 equations. It shouldn't take you that long. I had my 10-year-old son, Kelvin, follow these instructions and type it into the Desmos calculator to see if it works, and it does. Okay, so please do that if you're not familiar with it. And then once you have done that, then you can type in all the equations that's shown on these few pages. And I've also done some of them. Let me see which equations are there. For example, let me show you what I've done. First, I'll load it. Okay, this is equation. Give me a second here. So, for example, this is equation y equal to x to the power 1/3, or the cubic root. For anything like any kind of exponent that's not just the square root, then you have to type in the fraction. Okay, and I have here exactly how this is done. As you can see, I typed it in, and Desmos was able to graph it very nicely. And then remember, this button is just the right arrow. And your keyboard might either say right or say the right arrow, okay, not both. My son couldn't find the button that says both right and the right arrow. It's one or the other. All right, so next, let's look at another one that I did. Let's see, y equals to x to the power 3. Okay, here it is. So here is the graph for y equals to x to the power 3, and those are the buttons I used to push it in. So make sure you do this yourself. As you can see, it's just a few keys, so shouldn't be too much trouble. You just have to remember, follow the rules exactly. Okay, and then next, I have y equal to 1/x. Which is right here. Let's see, okay. So that is the y equal to 1/x equation. Well, my camera isn't zooming in for some reason, but you can kind of see it, okay. Why is the thing not zooming in? Ah, there it is. All right. So anyway, so that's y equal to 1 over x. And just to give you an impression of how this works. So be sure to type all this stuff in that I show here. Let me see. Okay, the next one is y equal to absolute value of x. Same thing, okay? And see, you type in those keys as it shows. Push shift and that other button together. My son couldn't find the button at first. It's on the right hand side, okay? It's there in every keyboard. So, so please find that thing so that you can type in the absolute value. Next, we need y equals to x squared. No? Y equal to the square root of x. Y equal x to the power 1/3. Didn't we already do that? I don't know. Oh, that's something else. Never mind. What else? I'm not sure. Let me see if I missed anything. Okay, here's another one. Here, well, yeah, you just go ahead and type that in. See, then the graph shows up very nicely. And next, this is y equal to the square root of x. Okay, now to type in the square root symbol, what you're gonna do is click this keyboard symbol down here. That will open the keyboard, and so that allows you to click in the square root symbol. Like this, see? If you click in the square root symbol, then the keyboard down here opens up, okay? You click it again to close it. So anyway, there's the square root symbol. I've circled there. You click it and it will show up right here, and then you can type stuff in. So anyway, and then the graphs also can be dragged back and forth. You just drag it like you drag other things on the in the in the computer. And then and there are other things that I will mention later as well. So that is the okay. I think that should be it. That's all the graphing I want to talk about. And with that, we should have come to the end of the section. Yep, so for homework, which is on page 200, I'm not going to read them out because there's a ton of homework. However, now before you panic, most of this homework is very short, and some of the homework, there are 12 problems that are actually sets of 3 problems. They're the same thing. You're just typing in a very simple graph, and you're required to zoom in and zoom out. And so please figure out how to zoom stuff in and out, and by pushing the plus and minus button on there. And if you have trouble, that's starting in problem 76. Now, if you have trouble, I will, of course, show it in the homework explanation in a little bit. So, so please do the homework that's listed in the below the video. Okay, and when you're done, I will talk about some of them. So now that you're done with homework, let's talk about it. First, I want to talk about problem 19. And we just need to know if y is a function of x. So problem 19, then 2x times y equal to 1. So 19. So we have 2x times y equal to 1. So then we can just push the 2x down, okay, across the division line to the bottom. Across the equal sign, down the division line to the bottom. So y equal to 1 over 2x. That is a function. Now, with the condition that x cannot be 0. Okay, as always, whenever you divide by something, x is always defined as not 0. So that is that's that. Next, let's problem 23, where we have x equal to plus or minus x equal to plus or minus the square root of 1 minus y. Now, remember this, then in this case, then x is not a function of y because it has two values. However, we're not wondering if x is a function of y. We specifically want to know if y is a function of x. So we need to plug y out of here by squaring both sides. Okay, so then it becomes x squared if you square both sides. And when you square something, both plus and negative becomes positive. Okay, so then we just have 1 minus y left. And as a result, then we can push the y to the other side, becomes positive because it has a negative sign there. And then move the x squared to this side, so it becomes negative. Always change the sign when you move stuff across the equal sign. So this situation becomes y equal to 1 minus x squared, which is a function. So the answer is yes to problem 23. Next, let's look at problem 25, where we have, so 25 says that y squared equals to x squared. Now at this point, to solve for y, then we have to have y then has to be equal, it has two options, okay? It equals to the positive or negative value of x. And we don't know which one, so therefore this is this is not a function as a result. So that's 25. Next, let's look at problem 33. Next, let's look at problem 33, where we have g of x is x squared, etc. And we're supposed to calculate g of x minus g of a divided by x minus a. And you might wonder, why do we want to do that? Don't ask, okay? And remember, x is not a, because if x is a, the denominator is 0, and that is not acceptable. So we always specify the denominator is not 0, which is what that sentence says. Now, okay, fine. So, so then how are we going to do that? Well, we're going to write everything out like it says, and then see what happens. So g of x is x squared. So this equation equal to x squared. So just, I'll copy down g of x. Oops, there's no 3 in it. So I'll copy down g of x right here, which is x squared plus 2x. Why do I have a minus here? Okay, x squared plus 2x. And then g of a is minus. Let's draw it in parentheses because you're going to be minusing a bunch of stuff. Okay, so g of a, then plug a in place of x, then we get a squared plus 2a. And a squared plus 2a is g of a. Okay, oops. So that's all g of a is. And then divided by, I continue to copy this thing. Remember, this has to be in parentheses for clarity, so that things are not confused. Anyway, so all of this is divided by x minus a. And continue writing, that equals to, let's see, we have, what we're going to do is rewrite this thing like x minus a, and then we'll rewrite it like this, okay? So we'll write it as x squared minus a squared plus 2x minus 2a. That is, here's the 2x, okay? There is minus a squared, which I write over here, and then minus 2a, which I write over there. So I sort of switch the positions. Why am I doing that? Because we're going to play a factoring trick on this thing, okay? All divided by x minus a. And so continuing, we notice that this is the difference of squares. And remember, what is the difference squares? Difference of squares says a squared minus b squared equals to a plus b times a minus b. Please remember this, okay? And so anyway, so this becomes a plus b, sorry, x. So x is now the new a. Well, the point is, it equals to this thing plus this thing times this thing minus this thing. Okay, so the first item plus the second item, and times the first item minus the second item. So that's what that formula says. And then continuing, in this part, we're going to factor out the 2, which then we have x minus a left. Okay, the whole thing will be divided by x minus a. And then we're going to cancel out x minus a for all these things. See, I mean, how did I know that there's an x minus a in there? Well, I didn't. This is just a matter of luck. Okay, we mess around with it and see, oh wow, check this. There's a common factor that you can cancel. Isn't that life is good, right? And so then we did that and then cancel out. Then all we have is x plus a and then plus 2. Being that these things got canceled out, this is all I have left. And that is the answer. Now, the reason we can cancel, by the way, is because x is not a. That is, x minus a is not 0. If it's 0, you cannot cancel it. You can't divide it either. You can't do anything. Okay? I mean, involved with division. You cannot divide by 0. But being that we have specified that x is not 0, then this cancellation makes sense. And therefore, that is the answer. Next, I want to talk about problem 53. 53, we only have the function on the graph, which is fine. All right. Now, we suppose to calculate what f of 0 is. So look down at 0. When x's value is 0, what's y value? X is 0, you look up, and y is 1. Okay, right in the middle there. So the answer for part A should be 1. Yep, I look at the answer, is correct. Secondly, when is f of x equal to minus 3? So we look down at minus 3. That is the y value of minus 3. When is x? Well, there is right here and over here. It appears to be plus and minus 2. Okay, these two bumps. And then, yep, it seems to be 2 and minus 2. So far, so good. Now next, let's look at problem 55. Now in 55, we have that oval-shaped thing there. It's called an ellipse, but that doesn't matter right now. The point is, is this thing a one-to-one? Well, it's not even a function, because a function can have only one value. And that is, if you draw a vertical line down, you should only hit it once. And is this thing one-to-one? Let's draw a horizontal line across. If it only hit once, then it's one-to-one. Right, and it hit 2 times, therefore it is not one-to-one, and is not a function either. It's not anything. So next, let's look at problem 57. Is this thing one-to-one? This one is, because if you draw a horizontal line across everywhere that you can tell, then it only hit the graph, the blue line, 1 time. Okay, so therefore problem 57 is a one-to-one function. Okay, and then one more problem I want to do is problem 76, which is just graphing the x squared function. Let me load it. Okay, now next, problem 76, we are supposed to graph y equal to x squared, which isn't it, but they also want us to change the range of the graph. That is, we wanted to graph it from, say, a small amount, okay, x going from 0.1 to -1, or a large amount, x go from 100 to -100, something like that. Now, to do that, I have, see, this is what I graphed on here. This is just a regular graph, but what I want to show you here is that to graph things, what you're going to do is you click this wrench symbol, and then stuff will open where you can change this. You can change this. Okay, you can change the range here to whatever you want. Okay, x going from 0.01 to 1 to, or whatever, or 100 to -100 to 100, anything. And then, normally, however, I'm not even going to bother with that. See this plus and negative minus symbol? Just push it one or the other, okay? They'll zoom this thing in and out to 0.01 or out to 1,000 or something. Yeah, just keep clicking that button, and that's what I did. And as a result of clicking plus or minus button, I have, okay, this is what I got for the, well, some of the answer of this problem. Okay, I did the two ends, two extremes. That is, I did the one that we go from, I have the two answers superimposed here. So we have, this is the -1 to 1 answer, where as you can see, that it is, the graph looks very, very flat, right? Because we're zooming in at the end. And then this other graph here is where I zoom out, where it goes from -100 to 100. And at this point, then the graph looks super narrow, okay, which is very interesting to see. And then Didn't I do something else too? Give me a second. So that is, yeah, that's problem 76. The last problem I want to talk about is problem 85, where we are supposed to type in the cubic root of x. Now, as you notice, I have two answers superimposed in here. But as you notice, the red line is the graph. Okay. As you notice, when we zoom in real tightly, the thing is just a vertical line. You can't tell the difference. Okay. This is from negative 0.001 to positive, and then on the other hand, if you zoom out to 1,000,000 both directions, then the whole thing just looks like a horizontal line. You can't see the difference, which I thought was very interesting. I didn't know this. Okay, I've never done this before, and I was not aware of this fact, so I thought it's really cool. And with that, that should mark the end of this section.